On this problem, we're multiplying two square root expressions in parentheses. So you remember how to multiply two square roots, right? We take the first to both and the second to both. First to both, second to both. So here we go. So first off, the root 7 goes boom, boom. He's going to multiply both of those. First to both, and then when we're done with that, the second one will go to both. Right? 4 multiplications. That's always how we multiply two things with two things. The first to both, second to both. Okay. And when they multiply, remember when it comes to roots, it's like prison. Outsiders with outsiders, insiders with insiders, right? If you go visit prison, you can, you're still an outsider. Outsiders can only really interact with outsiders, insiders with insiders. That's how roots work. So here we go. So root 7, that's going to make root 49. They can multiply, they're both insiders. Plus, and then root 7 times root 10, root 70. He's done. And now the 9 root 10 is going to multiply. What's going to happen there? The 9 stays on the outside, and the 7 times 10 makes 70 on the inside. Plus, and then the 9 root 10 times root 10. Again, the two 10s multiply on the inside to be 100 because they're both insiders. The 9 stays on the outside. Now, we can simplify this a little further, can't we? What is the square root of 49? That's just 7. No more root, right? Whenever you root a number, the root vanishes. He does his job and vanishes. What about these two in the middle? Now, you might wonder, can I break down that 70? You could try. It's not going to go anywhere. Let me show you. 7 times 10, then 10 is 2 times 5. Notice there's no pairs there. Like if I put that all together, I'd have just 7, 2, and 5. Nobody's coming out of the root. Nobody's making the jailbreak, right? Nobody's getting out. There's not 2 of anybody. There's just 1 7, 1 2, and 1 5. There's not a matching pair at all, so it's useless. So forget about it. Let me skip that then, right? You can only simplify square roots when after you break them down, there ends up being 2 of something, right? Then it's a 2 for 1 deal. But with root 70, these 2 root 70s, there's not 2 of anything in there. So just leave it root 7. Everybody see that? So now, well, can I add them? Yes. This is 1 root 70 and 9 root 70, which is what? 10 root 70. See, these guys are what we call like roots, meaning they have the exact same root. So you add the numbers in the front, just like terms, like adding, what if I was adding x and 9x? We all know that'd be 10x, right? Because it's 1x and 9x, right? Whereas if the back one didn't have an x, and this was just 1x and 9, then they could not add, right? You could only add like terms. They got to have the same letters, or in the case of roots, they've got to have the same roots. So the root 70s do have the same roots. They can add, and in that case, you add the numbers in the front, which is the invisible 1 right there, and the 9 to make 10. 1 root of 70 and 9 more roots of 70, 10 roots of 70. Okay, what happens with the thing at the back? Well, the 9 stays in the front, right? And what is the square root of 100? 10. Plain, regular 10, right? There's no more root. Whenever we do a root, remember, the root does his job and vanishes. So then what comes from that? Well, that's going to be plain old 7 again. 10 root 70. And what's 9 times 10? 90. Right? Again, we might wonder, where'd the root go over here? It vanished because I did the root, just like I did on the 49. When I rooted the 49, the root vanished, became 7. When I root the 100, the root vanished to 10. Now you might, let me answer a good question you might have in your mind. You might say, Mr. Chan, why didn't you break that one down? You totally could have. I could have just gone 10 times 10. And then 2 10s in, 1 10 out. Same answer. You get the same answer. See how that, or now you might say, oh yeah, but it's not all the way. Mr. Chan, you got to go all the way. Okay, I'll do that too. I'll go, okay, you're right. 2 5. No, truthfully, you don't have to. But okay, so what would that be then? 2 2s, 2 5s, right? Scribbly there. And then what would happen? 2 2s in, 1 2 out. There you go. 2 5s in, 1 5 out. What's 2 times 5? 10. See how any of these ways we do it, we're going to get 10, aren't we? And there's no more root. See how everything left the root? So my point is, you can do it any of those ways. The easiest way is just say, look, square root of 100 is just 10. That's the best thing, right? That's the quickest. Square root of 100 is just 10. If you have a nice one, like square root of 100 or square root of 49 over here, just do the square root. That's going to be the easiest thing. But if you want to break it all down and do the ship out, you can. It'll be the same answer. You can just do 10 and 10, that ship out 110, right? You can do 2 for 1 at any level. You don't have to keep going down below the 10s. But whatever. Easiest way is square root of 100. Now, we're not done yet. Last thing, I know this problem goes on and on here. 7 and 9 can add. Now, here's the mistake a lot of people make. Let me comment on that. They'll add these two. They'll go, oh, that's 17 root of 70. No. Why not? They're not like roots. Remember, you can only, let me write it over here. You can only add and subtract like roots, meaning if that 7 had a root 70 on it, then yeah, that'd be okay. You'd have 7 root of 70 and 10 more roots of 70. Yeah, then that would make 17 roots of 70. But it doesn't. They're not like roots. You cannot add them. So, well, then what do you add? You add the plain numbers. The 7 and the 90 make 97. You see, those can add because they're like, meaning they're just plain numbers. And then the 10 root 70 stays in the back, and that's our final answer. That's as simple as we can get it. Again, I can't add, so I just added the 7 and the 90. Does everybody see that? The 7 and the 90, because they're plain numbers. They don't have roots, so they can add. And I can't go, you might say, well, can I add the 97 and the 10 there? No, we're done right there, because again, those are not like roots. You can only add like roots. If that 97 had a root 70, then I could say 97 roots of 70 and 10 more roots of 70. Yeah, I could add them. But as it stands, no, I've got a plain old number like 97, and I've got a root, which is kind of like an x. So it's like looking at 97 plus 10x. Those are unlike. You can't add them. So it just stays as it is. And there we go.